Okay, now our experiment that we're gonna do here, the first thing we have to do is write a question. Okay, we have to ask a question. Give me a second. I need y'all to write this in your notes real quick. Okay, this is gonna be the question that we're gonna start off with, but y'all come back right after you write your notes. Okay, it's gonna be, what is going to happen when we mix oil / water and salt / water. What is going to happen when we mix oil and water and salt and water? Okay, that's going to be your first question. Okay, that's going to be your question.
In our journal.
Now our second one is going to be, and do it in your journal because you're doing your scientific method each time that we do these experiments. Now, someone before did this experiment. Okay, we're just replicating an experiment, but say someone had never done it before, like y'all have never done it before, right? So this is probably going to be the first time you've done this type of experiment and done it in experiment form, okay? I guarantee you have done it sometime in your life, or you have seen it done, but you never knew why it was happening, okay? That's a part of science. Things happen. And so we're guessing, well, why did it happen? You know, what caused it to happen? And that's science, okay? We make mistakes. Thomas Edison didn't say he failed 10,000 times when he made the light bulb. He goes, guess what? I found 10,000 different ways it just didn't work until I found the right way. So he didn't call himself a failure 10,000 times. He just, guess what? There was just 10,000 different ways that didn't work until I found out the right way. See that? So it's not failure when we make mistakes. I invite you to make mistakes when you're doing science. When we do math, what did I tell you? Make mistakes right now. Make it while I'm here. Because guess what? I can help you when I'm here. All right? So that's what science is about. Now, our question, we ask a question, what's going to happen when we mix these things, okay? Now, we're going to learn about our research. Our research, we kind of went through mixtures right here. We said that homogeneous would be salt mixed with water. We said heterogeneous is oil mixed with water, okay? And we got the definition. So we kind of divided it. Now we want to experiment with it, okay? Come up, my two little scientists. Now, on number 3, we were going to guess what's going to happen. Okay, number 3, y'all should be writing this down inside your book. Okay, we're not writing on our scientific method because we're going to use this again for another experiment. So we're going to save these. Now, the next one is guess a hypothesis. What is going to happen? Okay, guess what's going to happen when we mix the water and salt. Guess what's going to happen when we mix the oil and water. Okay, we're going to mix it for 1 minute. So I need y'all to fill the beakers at least halfway up. I meant the graduated cylinders. Grab this cup right here, grab this cup right here, fill it with water and put it inside there. Put them halfway up. Or a little bit more than halfway. That's good. That's good. This is nearby, close to it. That's fine. Now go ahead, add your oil and add your salt. In the meantime, Somebody take out the computer and get the timer. Got it? Set the timer. Get timer for a minute.
Starting.
Hold on, I get it. This doesn't want to stay on.
Wait, 1 minute?
Okay, you're gonna have to hold it, okay, when you're on there, okay, because it's gonna, you're gonna have to hold it tight, because it's gonna ready to come up, okay? Ready, set, ready? Let us know.
Already. Yeah.
Go, shake it. Did y'all write what you thought was gonna happen? Y'all should be writing down what you think is gonna happen. Write it down. That's okay. You can do it. What happened?
He restarted his.
But mine's still going.
It's still going. Okay. Let us know when it's 10 seconds down, okay? So we can count down with you. Getting tired, Griffin? Come on.
Tag team. This is not wrestling.
10.
9, 8, 7, 6,
5, 4, 3, 2, 1. Okay.
Oh.
All right. So,
My hand.
share with us what you think. What's gonna happen? What's gonna happen? What do you think is gonna happen?
The salt will disintegrate in the water, and the oil will separate from the water.
Okay.
I think it'll smell weird.
Anybody else got anything different?
Nope.
No, that's what we're going with.
I think it'll smell weird. Because it
Turn it
does.
off. Okay. What?
Oil?
I thought the water would kind of change colors and separate with salt on each side, but apparently not.
Okay. The oil's gonna float on top. What you got? Oh, look at you. You're getting even smarter. Oh, right. She's hitting something that we haven't got yet that we're about to hit.
Can I say that I think the oil will try to like make a separate layer than the water? Because I saw a video about this one time, so I think that's what will happen. And then for the salt, it's just, all the salt's gonna go to like the bottom.
So y'all can already see what's going on here.
I was right.
Most of the salt, if not all of it, dissolved. I don't think there's anything left at the bottom.
Oh.
DJ mixed
I
it.
see some at the bottom.
Yeah, she mixed it.
Yeah, just a
Barely
little
any,
bit.
maybe 2 or 3 granules on there, not that much. But as far as the water and oil is separating. Okay? Now, guess what? This experiment, go ahead guys, y'all can go sit down. This experiment is very important for different reasons, okay? We're gonna learn even more about this here later on tomorrow, okay? Or next time we have science, we're gonna learn even more about this situation, okay? And why the oil is above the water, okay? Which is what happened. And then we had the salt that dissolved in the water, okay? But guess what? Somebody was hitting it pretty good over there. She was talking about density. Oh my goodness, somebody was talking about density.
I said the oil is going to the mix to the bottom because the oil is dense.
Well, the oil's going to the top.
Dense than it's more dense than the water.
Well, the oil actually went on top because it's actually lighter than water. Yeah. Okay. Now we need to tell on our notes. Tell on our notes because the next question should be what happened. What happened with our experiment? So you need to say, okay, when we mix the oil with the water, like a few seconds later, you can already see it separating, right? Okay. You need to write in complete sentences because guess what? What if I wanted to come and read your notes, Stella? I need to be able to read your notes in complete sentences. I need to be able to duplicate what you did. Okay? So it needs to be in complete sentences and legible. Because some scientists made their stuff where it wasn't legible that we couldn't duplicate the experiments because it wasn't legible.
What if we don't want to share this information with everybody?
Well, you're sharing it with me, so we're going to write it to where it's clear.
Aww.
Now, on the other one, we can say, hey, look, when we mix the salt and the water, it looks like the salt dissolved inside the water, didn't it? But if you,
Still there.
it's still there, yeah? Is it still there?
It just
Matter
changes
can be
its
destroyed.
It what?
Matter can't be destroyed physically or created.
That's energy.
It
So-
has to change into the different states of matter, either a liquid or a solid. Right now, that salt and water is a solution, not a mixture.
It's a solution now? Oh my goodness, y'all getting there. Y'all getting so wonderfully smart. But not only did this became what?
A
If
solution.
even though it became a solution, now
still a
it's more
mixture,
what?
though.
Mixture.
Now it's more what?
Compound.
So
Dense.
when it compound, what'd you say?
Dense.
Dense, which, like you said, it's
Both
compounded.
of their
Compounded,
densities
dense.
are mixed.
It's heavier now. Okay. So guess what? What around the world is like this? What around the world is like this?
Seawater.
What'd you say, Bentley?
Seawater?
Seawater. Did you know? They used to make ships out of concrete, and they used to put it in the ocean. Yes, there's some. Look it up. There's some concrete ships.
Do they float?
And the reason why is because in salt water is more dense, so it was able to float. That's why you see these aircraft carriers the size of the school. And guess what they're doing? They're floating in salt water because salt water is dense. Now, if it would have been fresh water like this, I guarantee you probably those aircraft carriers wouldn't float. They'd bottom out.
That's what the boats, the bottom of the boats are like a pontoon boat is full of air, which makes it float.
Which makes it float. Now, not only is that, how can we use this every day? How do you see this besides that every day? How do you see this? How do you see that this could be used every day and then this could be used? Knowing that water and oil separates, how could that help us? DJ?
With salt and water, when you're cooking,
Hey, I'm trying to hear somebody.
when you're making certain types of food, you have to mix water with maybe other ingredients with salt. So you would have to mix it, and that's how it's more dense.
Okay. What do you got?
I'm just curious, what happens when you mix the salt water with the oil water?
Well, the oil water, we can find out later on. Yeah, we can find out later on. We can actually probably add a little bit of oil and we'll find out what happens. And see if it separates faster, separates slower because of the density that it's already done. But is there any way that y'all can see that the oil separated from the water could work for us? Now, y'all said, the salt dissolving inside water. Guess what else can dissolve in water? We could do the same thing with sugar, right? Sugar dissolves in it. So we can combine the two and it's going to dissolve and mix. We also use it, we can see it every day in sodas when we drink it. That is sugar and water already combined, right? Or it could be corn syrup, which is a sugar form combined. Kool-Aid, we make Kool-Aid. When we make tea, sweet tea, we mix it together with sugar and the sugar dissolves.
In the water.
Yeah, when we put salt in our food, it dissolves. Now, that's this experiment, how this can be used. But now we're tomorrow, gonna learn about the density. Now that we put salt in there, it makes it like fuller, okay? Now, this right here, how can water and oil not mixing help us in everyday life? How can that help us? Zebedee? Cooking? How? Tell me how in cooking. Because honestly, it is used in some way of cooking, but probably not the way you're thinking. I guarantee. It's probably that it's able to separate.
I didn't think that far.
Okay. Haley, what do you think?
Speaking of cleaning,
Oh my goodness, yes. How?
sometimes my mom uses those to like clean hands and other stuff like those.
You're so close to it. What else? How else?
Like science.
I know it.
Okay, watch this. I want to show y'all real quick. Bentley, what do you think?
It's used for cleaning when you pour the oil or something over a substance. It rises to the top, pushing all the dirt and grime with it.
Could, but I think the oil would still leave a film and stuff. So let me show you all this. So imagine this being a sink, okay? Excuse my drawing. So here's a little faucet and the water comes down, right? And so you have your little bowl sink. After you have your sink, guess what? You have a pipe that comes down.
The drain.
The drain. Then guess what? That drain in all restaurants and most sewers have this is called a grease trap.
A what?
A grease trap. What?
Because grease has oil in it, it's gonna separate because the experiment we just did, it shows that when we put water and oil together, they separate.
Exactly. So what they would do is they would have a pipe to allow the water to come through. This would fill up, and guess what? The grease would separate and come into this tank, while the water stays on the bottom and drains out.
That's so smart.
So every restaurant has to have one of these things inside it, and it's even our kitchen here has a grease trap in it. You'll have a machine that you'll see out there, and it stinks so bad because it's sucking up that grease, old cooking grease, and it's just mildewed and everything. And it smells like the worst sewage ever. I promise, it smells worse than sewage.
When you smelled it?
It smells worse than sewage. Oh yeah, because I've worked in restaurants for 30 years, so yes, I've been around it. I've had to fix grease traps. I have done everything with it. So grease traps, and then what they would do is you have a lid right here, and so the truck would come, and it get a hose and it pumps out that grease while the water's coming over here, and this is full of grease. So this right here helped us learn how to keep our sewage without grease going inside the water. And then guess what? That water goes back to a plant. Then in the plant, it ends up cleaning it and purifying it, and then they send the water right back to our pipes so that we can drink it.
Wait,
Yeah, that's what happens. All right, thank you.